SEAL Team Tech is a four-man team that is composed of myself, Andrew,
Me, Richard.
Me, Josiah.
And Carl right here.
We split up our project into several areas of focus. Carl was in charge of all our motors and the power supply. Josiah took care of our trigger system and then some accessories along with the laser. Richard took care of all the video processing and OpenCV, which was a ton of time, and I don't know how much time he spent on that. And then I just did joysticks and base structure. So basically getting joystick input and the base for our turret.
All right. I was in control of the motor control and the power supply for the turrets. For the power supply, I mainly had to supply the DC separator motor with a 12-volt DC source, and then the servo with a 6-volt source, which is composed of the picture at the top left, which was the 12-volt DC source, and then a buck converter to supply the servo with enough voltage. And then I also had a joystick that wasn't used in the final project, but the code basis was used for basically how everything ran. Then all of my stuff, as you can see in the far right picture, with the my servo, my separator motor, buck converter, and my joystick all together.
Okay, so this part was about installing the E-trigger and a bunch of sensors. And installing the E-trigger was basically taking apart the paintball gun and installing a mechanical trigger that would actuate the firing system on the paintball gun. This was done by using a relay, which would then actuate the trigger system on the paintball gun. Then on top of that, there was also a bunch of sensors that we used, such as humidity and temperature, which come in handy when firing a gun, as well as a laser, which helps to improve the accuracy of the gun and allows for more precise aiming.
I was in charge of the video processing and the safety aspect of the project. For this first step, we had to install the OpenCV, which would be used with the Pi camera that we implement to our using the Open motion sensor. So in that aspect, it took a real long time of getting the OpenCV to work. Using that, we actually started with using facial recognition. But at that point, the person would have to stand really close to the turret to even actually get their face recognized, and upon that, be fired at. So we actually switched to motion detection. We did not actually implement the motion detection with the turret itself, as opposed to moving upon motion and actually firing at that target. So that was a whole separate. We had two pies. We had one pie for the movement, one pie for the image processing, which the second pie would actually handle with the image processing. On the second figure below, it actually shows the motion detection actually scanning a person, and upon that, it says room status is occupied. In our project, we actually displayed the X/Y coordinates of our person that it detected. So for future updates, we would actually convert that into a real XY plane and actually try to get the motion detection move upon the coordinate system, the graphical coordinate system, to fire a person. And for the kill switches, we had one on the base mount, which killed power through everything, and we had a simple restart switch which was on the controller just to restart the program.
So I set up our joystick and the base structure. As you can see from the photos, base structure is made all out of wood. We use a large ball bearing Lazy Susan to actually provide the rotational for our turret. And we were going to have elevation, but we nixed that. So in the photo, you only see one support arm. There's a second arm that we actually added to support the gun. So turret's fairly simple design. But then the next thing I worked on that we actually implemented was our Bluetooth system. So hooking up an Xbox controller through Bluetooth on the Raspberry Pis is not easy. There's a lot of code you have to change, and there's a lot of parameters behind the scenes that you have to know to change and to reset to the proper settings so you can connect to the controller. However, once you connect to the controller, it is so easy to get to work. You can read the indexes using several different codes on the Pi that are already available or that are readily available online. So use these codes, find your basically the coordinates or what each button or trigger, what its code for activating is, and you just put that into a file that does whatever function when that's at current setting is met. So super simple, and it made it a lot of fun. It also is very easy to connect a USB controller, which is what we actually had to do when we were doing a firing test because the Bluetooth gave out on us. Higher. Oh, that got the corner of the shield. Nice. Okay. You okay?
Yeah.
It may not burst.
Go. Oh! Oh! Alright, that's enough. Oh, I just got me in the nut.
Yeah, perfect.